Okay, hi. Welcome to another masterclass session of Java fundamental class. So in this masterclass session, we're gonna learn about Java lesson 3, which contains useful libraries. So let's start. First, here's what we are gonna talk about. Our agenda: data structures, generics, solid principles, files, input, output, exercise, and lesson information. At the end of the session, we are gonna have a little discussion about questions you have, so you can post them and I will answer. My name, by the way, is Joseph, and I am in charge of helping you out through this masterclass session. So first, we're gonna talk about data structure. In lesson 3, we're gonna learn about two types of data structure: arrays and lists. So basically, in arrays, we have two types, or two subtypes of arrays, which is simple and multidimensional arrays. And in the other hand, list, we have array list, hash maps, and linked list. So we're gonna first start with arrays. So think about arrays as a one-dimensional box that has many boxes. So here you can see, for example, a locker. So a locker will be a really good example of arrays, which is a row, and inside that row you have like places you can store things, but these places are separate. So the length in an array is the total size of the array. So for example, here in this image, we have an array of 5 elements, but the length of the array will be the index of the array will go through 0 to 5. So here we have the array index, and here we have the array elements. So we have 6 elements, 1, 2, 3, 4, 5, 6, but the index are going to be from 0 to 5. So arrays helps us to store data in just one place. As I was talking about, lockers. So basically it's one-dimensional array with 6 elements in this example. Okay, now multi-dimensional arrays. So multi-dimensional arrays, think about as if you have one array, and inside every array section, you have another array, but in an horizontal way. So this one is vertical way, and the other one is horizontal way. So it's like a matrix. So you can see if I had a locker, this one will be one-dimensional array. And here we're gonna have one-dimensional array, but inside every section of that array, we're gonna have another one-dimensional array. So this is how we talk about multi-dimensional arrays. Okay, now that we have talked about arrays, we're gonna talk about array list and linked list. So if we go back, when we declare arrays, they are fixed size. So you cannot edit the size of the array. So maybe in here, we have a array with 6 elements. Maybe you want it to be just 5. You cannot delete this space. You need to create another array with 5 space, and not delete the last one. So array list helps us do that. So for example, array list and linked list have something called dynamic feature. So the dynamic feature let us change the size of the array. So for example, here in image number 1, we have 4 elements. So it's an array of 4 elements. And the really curious thing about array list is that every node, this block, we're gonna call it node. Every node makes reference to the next node and the previous one, except for the tail in the previous one, in the next one, and in the head with the previous one. So every node has has the address of the node before or the node after him. So what if we want to add another one, another space? With arrays, we cannot. Like we have the same array list and we want to add another one, another space. With arrays, we cannot do that. We need to make a new array. But with array list, we can. We can just simply add another node, and that node will have the reference of the node before him, and that's it. So array list and linked list gives us dynamic feature, and array list has static feature. You cannot change the size in runtime of an array, but basically they are mostly the same. Another thing we're gonna see, and this is like really important, and it has dynamic features as well as the array list and linked list, is that hash map. So hash map, think about as a dictionary. So it's a key value pair structure. And what did I mean with that? Well, you have a key, and if you place a key, you will retrieve a value. So every key is associated with some value. So for example, in this image, we have red, which associated with the RGB color of the red color, or green, which is associated with the green RGB color. So in here, arrays and array list are accessed by their index. So if I have this array, for example, and I want to get the second element, I will say, give me the element which is in the position 1 of the array. Do you see? I access the array by his index. So index 1 will give me the second element of the array. But also here in the multidimensional array, think about it as a vector. If you want the element which is in the row 0 and the column 1, you say, give me the array which is in the row 0, column 1. And this one will be the element. So as you can see, we access arrays with their indexes. And also array and linked list, array list and linked list. They are dynamically, yes, but we can also retrieve their values by accessing their index. So for example, I want the number 1 element. So the index is number 1. So something to notice, it is that here array list and linked list are starting their index as in 1. But in arrays and multidimensional arrays, the index starts with 0. Okay, so as I was talking about hash maps, if you want to access the value, you access that value by the key, not by his index. So basically, it's like a dictionary, as I told you before. So if you type, give me, maybe I want to say, give me in a hash map, give me the value that is relational with the key red. So you're gonna retrieve the RGB red color. Okay, so next one. Another thing we're gonna talk about is generics. So Java is a type-safe language. That means that we cannot change specific memory. I mean, everything is safe. The memory that we manage here is safe. And also, we have something called polymorphism, which is the ability of an object to take many forms. So in this case, let's see an example. This example. This example doesn't use generic. So first we are creating a list, but wait a second. Of what type is this list? It has no type, right? So in here, we add a string, which is hello, and we are placing this hello string value inside the list. And then we're getting the value by his index, which is the 0 element. Is the first element we have in the index 0, right? So we're getting it, but we need to place this thing right here, which is a cast. So basically it's saying, as we don't know the type of this list, we don't know what type of element will retrieve us if we get the 0 index. So we are casting that value, hoping it's a string. So before generics in Java, we have to do this thing, and we have like a lot of troubles using that stuff because we have like never know what type of data it's inside the list or inside a structure, and if we get confused or we make a mistake with something, we will get an error because it was not clear about the type of the element. So that's why generics born. If you see this example, it says list, and here we have a strings tag. So basically it's saying that this list is gonna hold strings inside of it. So list, new array list, in its strings, it said add, and then here we are retrieving that element, but we don't know, we do not have to cast the element. So let's see this example running. So I'm gonna show you here as generics. So in here we have the generics class. Well, this one is called generics1, and in here I have a public class, which is the main class, and the list one. So we're making a list here, and we are adding the hello string, and then in here we are retrieving the string and we are printing. So let's see what does this thing print to us. So I'm gonna make this a little bigger so you can see. Hope it sees. So I need to go to OneDrive, which is the place I have the code. So let's gonna run this example. So to run this example, I type Java and the generics1 class. So here's the output. The first one says no generics, it prints hello. Generics prints hello, so it prints the same. But here, let's gonna see what happened when we compile. So at the time of compilation, we have some warnings and says, has unchecked or unsafe operations. Recompile with xlint unchecked for details. And what's the problem here? It's because in some of the code, in some place of the code, we are not using generics. We are making unsafe typing. And that's right here. So when you are programming, you need to be clear about generics and how they work and how you use them. So basically, it's like a type safe for Java. Okay, so let's keep moving. This one is another example. So also generics are created to, like, for example, a method. You want to create a general method. So you want to print an array no matter what the type was, or no matter what the type is of that array. So for example, if you make a specific print method for every type that you have of inside an array, you will need to have, in this example, for example, 1, 2, 3 methods just for printing, and the code will be mostly the same. So using generics, you can make a method to make use of a generic type, which in this case I will be placing E as my generic type. So let's review this code. So first, we are making an integer array. Second, we are making a double array. And last one, we're making a float array. And then we are creating a method called print generic array. So what this method does is says it will return a generic value. So we don't know at the time of compilation what type of value will return. And it says that it will have a input array value, which we don't know the type of the array it will be at completion time. And then we're gonna iterate into all the elements, and we're gonna print the elements of that array. So as you can see, doesn't matter what type of array I sent right here to this function, it will print the array. So that's the goal of using generics, to manage different types with just one method. So let's see how it works. I will run this code. Let me show you. Okay, we have some troubles. Let me see. I think it's okay. So it's called generics to serve. So in here we have the print of the int array, have the print of the double array, and we have the print of the float array. So as you can see, we use just one method to receive many types. So generics gives you that ability to make methods that receives different types, and you can make the handle of those different types inside your method. So basically generics helps you to type safe language. So it's safe to modify and work with a array or structure that has defined his types. And also generics gives you the ability to work with different types using just one method or one class, and that's really cool. So let's keep moving, and here we're gonna see about solid principles. So inside lesson 3, there are many videos about solid principles, and also there are many examples about solid principles. So I'm going to talk about a little shortly about the different solid principles that we have. So the S stands for single responsibility principle. So in this principle is like, for example, it will be a class with just one responsibility, just one thing to do, not many things to do. And that's a really good solid principle. So the other one, O stands for open close principle. And what this says is that the method or the class needs to be open for extension, but closed for modification. So the method or class that we type or program doesn't need to be modified, but it basically just needs to be extended. Okay, second one, list of substitution principle. This one says that child's members could be replaced, father's objects could be replaced by child's objects. So for example, in here, maybe I want to make an app of birds, and I want to have many birds, right? Or I want to have an array of birds to store different birds inside that array. So for example, I will say, I will make an array of quetzals, which is a type of bird. And that array would only have the ability to store quetzals in their sections of that array. But what about if we make another bird? We cannot use that array that we have just declared just only for quetzals. So what we need to do is a general class called birds, and then classes, like for example, the quetzal class that will extend from the general class birds. So if we create an array of birds, you can place different type of birds inside of it, not only quetzals. So that's a really cool principle that it's really good to use, the least scope substitution principle. The I stands for interface segregation principle. And what does this says is that in interface needs to be small. Interface doesn't need to be general. It needs to be specific. So that's the thing with the why. You need to have interface just for the things that you need, not generate. And the last one is D, dependency inversion principle. So for the dependency inversion principle, it says that high-level models do not depend on low-level models. So for example, I have a high-level models that checks the money. It doesn't need to depend of the low-level model that prints the quantity that I just calculate in the high-level model. It doesn't need to depend on him. It needs to work. So basically, the high-level models needs to work fine without the low-level models. And those are the solid principles. Once again, you're going to see a lot of videos about solid principles in your lesson. This is just an overview about the solid principles that you're going to learn. And also you're going to see about code examples of it. So we're going to talk about files and input output. So in files input output, we have different things, or we have different classes. Here, the file input stream, the file output stream. We use file input stream to read, to create an inner buffer, which is the buffer where you're going to receive different information, or you're going to read different information. File output stream, where you're going to send different information. So in file input stream, you use the method read to read different information. And in the file output stream, you use write to send different information. Also, this one is really cool class called scanner. And in scanner, basically it works with tokens. So it tokenizes the buffer, and then with the function hasNext and next, you can go through the different tokenized that scanner just has made in the buffer. So hasNext tells the buffer if there is another token to read, and next tells the buffer to read the next token that is existing. So scanner works with buffer reader and file reader. So you need to use scanner with buffer reader and scanner with file reader. We're gonna see an example of that later. And also object input stream. Object input stream gives you the ability to cast objects in text. So for example, you have an object typed in text. You can cast it to object like in object in Java programming language. So you can cast it with here read object. We have an example of code with this object input stream and object output stream that you will like it. We're gonna work with JSON files, and that's really cool. So let's see an example for a scanner. So for example, here in read scanner. Okay. So in read scanner, we have this text. This one is called example txt, and we are going to read this example txt using a scanner. So as you can see, it's a simple text file that says hi ADX. This is an example of input output, blah 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 blah, and funny faces. So here is the class that we're going to use to read that text. So first of all, we have to import scanner class, and we have to import file reader. So remember, as I said before, scanner goes with buffer reader or with file reader. So in here, we have read scanner, and we're using scanner class and file readers class. So this one is our main method. And here we create the buffer. So the buffer says, we're going to create a new buffer in, which is type scanner. And we are going to get inside the buffer a file reader. And that file reader will read the example txt file that we just created right here. And here, this line is something cool. So remember before, as I talked about, so what the scanner does is that it tokenizes the buffer. So it separates each buffer with the token that we give. So in this example, this token means new line. So what it's going to do, it says that scanner will separate each part of the example txt file by a new line. So what you will see is hi dx will be the token number 1. Token number 2 will be, this is an example of input output, because it separates here, there is a new line included right here. So it tokenizes for the specific char or token that you give, in this example, new line. And then we're going to read. So reading, as I talked before, has next tells you if you have another token right in the buffer or you are done with all the tokens inside the buffer. And in here, we are just printing the buffer that we have. So here you see the scanner, and we're getting the next token. And at the end, we need to remember that we always close buffers. So we're closing the scanner buffer. So let's see how it works. So I will just run this example, and that's it. So as you can see, we have used Java read scanner, and it prints hi dx. This is an example of input output, blah 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 blah, funny faces. And that's how scanner works. So for example, let's see if I change something. Let's save. Run the program now. You see that? I left 2 new lines here, and it takes those 2 new lines to the console and all the new things that we just type in. So that's how basically you read a file using scanner and file reader. Okay, let's keep moving. So for your first exercise, which is exercise number 1, I'm gonna give you a little help here. This is a pro tip. So it's the exercise called Toy Store Manager. So the goal is to classify and sort a toy store before printing the values. So I give you this idea, and I give you the idea. You can use hash maps or lists. But in this example, we're implementing lists. So hash map, you can use like a toy dictionary. So you can say like baby toys, and you can print all the baby toys that are inside that category. Or for example, boy toys and all the boy toys that are in the category, or something like that. Or just a list with all the toys. So let's see this example. So I have this example right here. It's called sort list. So in the sort list, we have many different things. So first of all, we have here that we have declare or linked list, and Do you see here? We are using generics type. So we are saying that this linked list will store string values, and that's for sure. And then we are placing different names here. So this is not the choice that we talk about later, because you need to do this by your own. So in here, what we are doing is that we are sorting names. So first of all, we place Brandon in the first place of the linked list. Then we are placing Libby, then Rebecca, and then Andrea. So we have right now these four different names inside our linked list. But let's see, I'm going to show you, they are not in order, they are not sorted. So as you can see, the first print is of the objects in this order. So as we enter them, so Brandon, Libby, Rebecca, and Andrea. But then this line right here, and which I'm going to tell you that it's really great, is that this line here, it sorts the array or the linked list or the array list that you have and use natural order. So for example, if you are using names, it goes from the little one to the bigger one. Or if you are using letters or strings, it's just the alphabetic order. So for example, if here we are sorting the names, this line sorts, and we are sorting the names, then at the last print, what we are getting is the linked list in order. So here, A goes in the first place, B in the second place, L in the third, and Rebecca in the fourth. Because of the first letter that they have, it has the alphabetic order. Okay, so that's the tip to make your exercise, and you should take note of that. Okay, let's keep moving. And we are already mostly done. So I'm gonna talk about general info inside this lesson 3. So inside this lesson 3, you will find 3 exercises. These 3 exercises are for normal users. So the first one is Toy Store Manager, which I give you a little tip right here and right here. And the second one is a quiz about data structures. So you're gonna try to answer that quiz with the array linked list knowledge that you achieve in the lesson. And then the third one is a nutrition API, which you're gonna make a nutrition app to calculate nutrition things. And last one, for the extended ones, for the certified users, you're gonna have different exercises. First of all, find duplicates. And that's really cool because you are gonna be challenged to find duplicates inside an array without modifying the array. And that's a really good challenge. And second one, you're gonna be a restaurant manager, but you're gonna code that restaurant manager with solid principles. It needs to be with solid principles, so it could work really cool. Okay, so it's time for questions. I'm gonna pause this video and I'm gonna look at your question if you have some questions. So just give me a second. Okay, so I think at the time we don't have any question at the chat, but if you have questions, you can post them at the forum, and we are gonna answer it. I will just wait. I think no one is having questions right now. Okay, so you can leave me a comment in the forum or yeah, in the forum on here, and I could answer your questions if you have questions. So thank you. That will be for today, the masterclass session. Have a nice learning.